In this video, we're going to look at some important trends for energy use. First, we're going to look at what the picture of energy use looks like around the world. Second, we're going to look at how different energy sources produce different amounts of emissions. And finally, we're going to consider why electrifying our energy use as much as possible is going to be one of the key solutions to fighting climate change. Let's begin with some of the worldwide trends in energy use. This graph shows two important pieces of information: the year and the amount of energy that's used and how it's changing over time. The energy use in this graph is expressed in something called terawatt hours. A terawatt hour is basically a really large amount of energy, and it can be a little bit tricky to grasp. But one thing to keep it in perspective is to understand that a terawatt hour is about the amount of energy that 70,000 typical or average American homes would use in a year. So again, the United States is one of the largest energy users, so this is a lot of power, but this will help keep it in perspective. Now, when we look at the story of worldwide energy use back at the beginning of the 19th century, way back in the year 1800, we see here that nearly all of the energy being used was traditional biomass. This is essentially a fancy way of saying things like wood, animal dung, and peat moss, which were often burned for heat, and to do things like blacksmithing, so small industrial practices. Beginning about 50 years later, in the year 1850, this is when the Industrial Revolution really starts to kick off in England, and this is where we start to see coal use really starting to pick up. In the beginning of the 20th century, this is where we start seeing oil and natural gas become more commonly used. When we fast forward to today, this is where we start seeing a small amount of our worldwide energy use being powered by renewable sources of energy, nuclear power, and other low emission sources of energy. So the two really important trends that we see on this graph are that overall, over time, the world's energy use has gone up. So again, we're using a lot more energy than we did way back at the beginning of the 19th century, about 16 times as much. So this is because of population growth, but this is also because we do more with our energy. So back then, we didn't have things like cars or trains, and obviously to have those kind of inventions and to power them, it's going to take a lot more energy. The second really important trend is that we add sources of energy without necessarily giving up old ones. So you might think that something like traditional biomass, wood, and burning things like wood and dung would have gone out the window, but in fact, this is still a significant source of energy, especially in poorer parts of the world. So we haven't given it up, but we've simply added it on top of everything else. We've done the same thing with coal. So coal is the oldest source of fossil fuels that we're really exploiting, but we still continue to use a lot of it today. So we're adding new sources without necessarily getting rid of old ones. Unfortunately, a lot of these old sources, as we'll see, are high emission sources, so they generate a lot of greenhouse gases. So one thing that we'll have to do in the future is to increase this small share of relatively green sources of power that we see up here and decrease these older sources that we've relied upon for hundreds of years to power our societies. Now, another important trend that we see in worldwide energy use is a point that we brought up in the previous topic when we looked at the Kaya identity, and we talked about how things like wealth can contribute to emission sources. One of the things that we know is that people who live in wealthier countries like Canada and the United States tend to use more power than people in poorer countries like China and India. China and India, however, are increasing the amount of energy that they're using, and as a result, they're also increasing their emissions. So one of the stories that we also see that's an important energy trend is that as wealth tends to increase, energy use tends to go up, and because a lot of energy produces greenhouse gases, wealth tends to make emissions go up as well. So this is another important point that we want to keep in mind. However, we do also want to point out that because India and China are not as rich as countries like Canada and the United States, per person or per capita, they're still emitting less than we are here in North America. So again, an important point that we want to keep in mind is that wealth really influences the amount of energy that people use and the amount of emissions that they're producing. The reason why the sources of our energy production matter is summed up in this graph. And what this graph highlights is how much emissions we're producing for creating the same amount of energy from different kinds of sources. This includes all of the things that would go into a power plant. So this includes, for instance, the emissions that we create building a power plant or manufacturing something. So the reason why we have emissions even for relatively green sources like windmills and solar power is because some of the electricity and fuels that we use to manufacture those things will create some emissions. However, what we see is that a lot of the newer sources of energy produce a lot fewer emissions. Nuclear, wind, and solar are all great because they produce very, very little. And this is one of the reasons why a lot of people want us to switch to these sources to fight climate change. But you'll see here that they only account for a small portion of global electricity production. So only about 20% or 1/5 of the world's electricity is produced by these sources. Hydropower is relatively clean as well, but it does have more emissions than solar, nuclear, and wind. And part of the reason why is that when dams are installed, they will flood large areas, and those large areas can actually accumulate basically biomass or plant matter. And when that plant matter starts to break down, or things get caught behind the dam, they'll start to break down underwater. And one of the things that you might remember from last week when we talked about rice farming is that when things rot underwater, they're rotting without oxygen, and rotting without oxygen produces the greenhouse gas methane. So dams essentially make this process more likely in the areas that they flood, and basically when biomass accumulates behind a hydroelectric dam, it can break down without oxygen. So hydropower does produce more emissions than a lot of other green sources, but it is still relatively low. Hydropower produces the most of the world's green electricity as well, and it accounts for about 12%. Biomass has a really big range, but it is less green than a lot of other sources. So biomass would again include things like wood, which is commonly used in some electricity plants, particularly in Northern Europe, but it's not necessarily as green as some of the sources that we have listed down here. Natural gas, oil, and coal are examples of our fossil fuels, and you'll see that for all of them, they have much higher emissions. Natural gas is sometimes talked about as a relatively clean source of energy, and compared to oil and coal, it is, but notice that it produces a lot more greenhouse gas emissions than things like wind, nuclear, and solar. So while natural gas is better, unfortunately with climate change getting worse, this level of better isn't good enough. So we're going to have to phase out natural gas along with other fossil fuel sources. Now, oil is an interesting thing because we don't typically use it to generate electricity, but we use it instead to power things like cars, and when we burn it for powering our cars, it's still going to release a lot of those emissions. So oil is very, very dirty as well, and it produces a lot of greenhouse gas emissions. But the worst overall is coal. And coal, unfortunately, is still the most commonly used source of electricity worldwide. About 36% or 1/3 of all of the electricity that we generate is coal powered, and it produces the most emissions overall. And again, this is partly because coal electricity is our oldest electricity technology. We've been producing it this way for the longest period of time, and some of these plants are extremely old. And a lot of countries don't want to necessarily retire them or shut them down prematurely. So this is going to be a big problem, however, if we keep burning coal this way, because the amount of emissions that they're producing is so high. And another thing that we'll also see is that a lot of these emissions that make make climate change worse, are also making other problems like health problems worse for people as well. So this is one of the important things that we want to keep in mind. Coal, oil, and natural gas are all producing too many emissions, and we want to stop using them as much as possible, and we want to switch to much greener sources of energy like nuclear, solar, wind, and hydroelectricity as much as we can. One way that we're going to solve the problem of energy emissions is through electrifying everything. This is a program that a lot of science journalists and global warming researchers have talked about as one of the ways that we're going to tackle this problem. And the reason why electrifying everything is a solution is because of two reasons. First of all, it is very difficult for us to figure out how to make a low emission source of fuel. In a future video, I'm going to talk a little bit about ethanol, or a fuel that we actually can manufacture from corn and other plants. About 15 years ago, a lot of people thought that we would use ethanol to power our cars, our buses, our trains, and everything else. And they thought, well, it comes from plants, and plants actually suck up a little bit of carbon from the atmosphere. So manufacturing fuels from these things could end up being green. It turns out that what we now know is that they're not as green as we thought. It takes a lot of energy to make fuels from things like corn. And when we actually do the calculations and we research it carefully, it turns out that this apparent solution doesn't work so well, and it still creates a lot of emissions. So coming up with a direct substitute for things like oil and coal is extremely difficult in a way that produces very few emissions. So we don't have a good solution there, but it turns out that we have a good one with electricity. So as I pointed out, we know how to make electricity low emissions because we have a lot of different technologies that can do this. We've had hydroelectricity for over 100 years now. We've had nuclear power for about 50 to 60 years, and even solar and wind have been proven for a number of decades now. All of these are relatively low emission sources, and we know how to use them to generate electricity. So if we can make more of our things powered on electricity and fewer things on fuel, then over time, we're going to make our economies and our production and our energy use a lot greener than it was in the past. So in order to explain the idea of electrifying everything, I want to bring up a couple of examples that are relevant and are becoming more common in today's society. First of all, consider how you might cook on a stove. For a long time, people considered natural gas stoves to be the superior option because natural gas heats up quickly and it's more responsive. By contrast, a lot of the old style electric stoves get really hot, they're dangerous, and they don't work as quickly. So it's easy, for instance, if you're cooking on an old-fashioned electric stove, to accidentally burn your food. The problem is that cooking with gas isn't perfect either. So the most obvious problem is that when we burn natural gas to cook our food, we're releasing emissions like carbon dioxide. We also know that natural gas in our stoves in our home can leak methane into the atmosphere as well, which again is another potent greenhouse gas. On top of that, we also know that a lot of the emissions that are created in the home stay there and can actually cause health problems like asthma for people. So there have been studies done that show that children, when they grow up in households that have natural gas cooking, are more likely to develop asthma than kids who grow up in households with electric stoves. So there's a lot of reasons, not necessarily just the ones related to greenhouse gas emissions and climate change, that mean that it can make sense to switch how we're going to cook our food in the future. Electric cooking, by contrast, does not create a lot of these health problems in the home. And if we're powering the electric stoves with a source of energy that is green, then we are also reducing the emissions at the power plant as well. One thing we do not want to do is to make natural gas electricity to power our electric stoves, because we're still going to get the emissions from the power plant. But if we can figure out ways to power our electric stoves from solar panels, from wind turbines, from hydroelectricity, or nuclear plants, then those sources of energy are also going to have low emissions, and our cooking isn't going to make climate change worse. Another interesting thing about electric cooking technology is that there's actually a new form called induction cooking, which is much more efficient and it's much more safer, and it actually is faster than a lot of the old style electric cooking. So we actually have not only ways of electrifying how we cook, but we actually have new technologies that will make it better than it used to be in the past. So there's a whole host of reasons that we want to switch, but this is one example of where we want to electrify something to reduce the amount of emissions that it produces. Now, cooking in our homes is a relatively small contributor to our greenhouse gas emissions. Transportation and heating and cooling are much bigger ones. And we typically use fuels like diesel fuel to power our trains, gasoline to power our cars, and we typically use things like fuels or natural gas to heat our homes as well. The good news is that we have technologies to electrify these things, and in many cases, these aren't new technologies either. So take an example of mass transportation like trains. Early trains, like streetcars, were often electrified, and while we've moved away from that technology, we could easily do it again. We could also electrify transportation between cities so that if you needed to travel long distances, like say you needed to get to Toronto, rather than hopping in a car or even a bus that's powered by diesel fuel, you could get in a train that's electrified instead. And as we get our electricity system more and more greener, the train would also become greener as well. With heating, one of the reasons why we use natural gas is because it's relatively good at producing large amounts of heat. If we were to use electricity to produce our heat in old-fashioned style heating systems, we'd need a lot more electricity than our electricity system currently has. The good news is that we're now moving towards technologies like heat pumps that make heating the home much more efficient. So a heat pump basically works not by creating heat by burning electricity or burning fuel, but by simply moving heat from outside into the home. So if you want to make your home warmer, essentially what a heat pump, like this guy is resting his elbow on, do is they basically condense the heat from outside and help to move it in. Heat pumps will work in all but the most coldest of temperatures, and the good news is that they require a lot less electricity to move heat than to create it from scratch. And as a bonus, heat pumps will also work in reverse, in which case they function like an air conditioner. So if your house is too hot, the heat pump will actually take the heat from inside and push it out instead. Now again, these sources of heating would require a lot of energy, and if we can electrify them, then essentially we're going to get away from a lot of the problems that we would have by burning things like natural gas or heating fuel, which are used in a lot of Canadian homes today. So again, because we can make electricity greener, the more things we can electrify, the better off we're going to tend to be as we're trying to fight climate change. So to summarize some of the main trends that we've discussed in this video, the problem is that the fossil fuels like gas, oil, and coal are producing most of the world's energy and electricity needs today. The problem is that because of those emissions, they contribute to global warming. And if we want to fight global warming, we're going to have to reduce and eliminate our use of these kinds of energy as fast as we can. The good news is that we have many ways that we can produce green or low emission sources of energy. And the more that we switch our electricity system to solar, wind, hydro, and nuclear, and the more things we can make run off electricity, the better off we're going to be. And this is why people talk about electrifying things like our cooking, our transportation, and our heating and cooling. Because if we do that and we switch to these kinds of sources, then we're going to be able to fight global warming.